Hello friends, let us recall about the divergence and curl. So yesterday we have learned that if say f n which is equal to f1i plus f2j plus f3k is a vector function, and of course it should be differentiable also, then divergence of f is del dot f. And we can find out divergence as del f1 by del x plus del f2 by del y plus del f3 by del z, and curl of f is del cross f, and that is we can find by the evaluation of the determinant I j k del by del x, del by del y, del by del z, f1, f2, f3. Now we know that let us take this r as a position vector. So that is r is xi plus yj plus zk, and let us write this r as magnitude of r, that is nothing but root of x square plus y square plus z square, or you can say r square equal to x square plus y square plus z square. So we take one simple example that find the divergence of r and curl of r. So r is xi plus yj plus zk. Divergence of r, so that is del dot r. So this is x is our f1, y is f2, z is f3. So del by del x of this f1 is x plus del by del y of f2 say is y, and del by del z of f3 z. So del by del x of x is 1, 1, 1, so 3. So divergence of position vector r is 3. Let us find the curl of r. So curl of r is determinant I j k, then del by del x, del by del y, del by del z, then vector r. So first component x, second component y, third component z. So that is equal to I, this is del by del y of z minus del by del z of y minus j del by del x of z minus del by del z of x, and plus k del by del x of y minus del by del y of x, and we see that del by del y of z is 0, del by del z of y is also 0, so this is 0 I. Similarly here also del by del x of z 0, del by del z of x is also 0, so this is 0 j, del by del x of y is 0, del by del y of x is 0, 0 k, and so that is 0 vector. So curl of r is a 0 vector. Let us take one more example. Let us prove that divergence of gradient of f is del square f. See, this del square operator is del square by del x square plus del square by del y square plus del square by del z square. That is del square operator. It is also called a Laplacian operator. So we want to prove that divergence of gradient of f is del square f, or even in symbol you can write del dot. Divergence means del dot. Grade f, that means del f. So del dot del f equal to del square f. So let us solve this example. So first of all, gradient of f, so that is del f, and we know that is I del f by del x plus j del f by del y plus k del f by del z. So this is gradient of f. Now we want divergence of gradient of f, or you can say del dot del f. Now we know how to find divergence. So this is the first component. We call it is like say f1. This is second component f2, and this one is third component f3. So what is divergence of this gradient of f? This is del by del x of first component, and first component is del f by del x plus del by del y of second component, that is del f by del y, and plus del by del z of third component, that is del f by del z. And so this is del square f by del x square plus del square f by del y square plus del square f by del z square, and that is nothing but operator this del square f. Next example, let us prove that divergence of curl of any vector say v is 0. So let v vector is say v1i plus v2j plus v3k. Even in symbol also you write like this, del dot del cross v is 0. Let us first find curl of v. So curl of v is I j k del by del x del by del y del by del z, then v1 v2 v3, and so this is equal to I del v3 by del y minus del v2 by del z minus j del v3 by del x minus del v1 by del z plus k del v2 by del x minus del v1 by del y. This is our curl of v. So this one is the, you can say first component like f1, this one but with the negative sign here is f2, and this one is say f3. So we want to find divergence of curl of V. That means del dot del cross V. But this is curl of V. So we want to find divergence. So del by del x of first component. So del by del x of del V3 by del y minus del V2 by del z. Let us take minus sign inside. So plus del by del y of second component. So minus del V3 by del x and plus del V1 by del z and plus third component. So del by del z of del V2 by del x minus del V1 by del y. Now take the derivative. So it's a second derivative now. Del square V3 del x del y minus del square V2 del x del z, then minus del square V3 del y del x and plus del square V1 del y del z, then plus del square V2 del z del x minus del square V1 del z del y. Now the partial derivative like del square V3 del x del y here and here, del square V3 del y del x, they are equal. We know that even in first semester, and with here they are with opposite sign, so they get cancelled. Similarly these two, del square V2 del x del z also and del square V1 del y del z also, so you are having 0, and so divergence of curl of V is 0. Let us take next example. Like curl of gradient of f is a 0 vector. That means curl means del cross gradient f, so del f, and that is a 0 vector. Divergence is a scalar, curl is a vector. So let us first find gradient of f. So gradient of f equal to I del f by del x plus j del f by del y plus k del f by del z. So this is gradient of f, and so this we can consider like first component, this is second component, and this one is the third component. Now we want curl of grade f. So del cross del f, so that is nothing but I j k del by del x del by del y del by del z, and now this is first component. So del f by del x del f by del y del f by del z. Evaluate. So this is I. Now del by del y of del f by del z, so that is del square f del y del z, then minus this one del by del z of del f by del y, so del square f del z del y, then minus j del square f del x del z minus del by del z of del f by del x. So del square f del z del x and plus k del by del y del by del x of del f by del y. So that is del square f del x del y minus del by del y of del f by del x. So del square f del y del x, and again we know that del square f by del y del z is same as del square f del z del y. So this is 0i, 0j, 0k, and so that is nothing but a 0 vector. So curl grade f is a 0 vector. Let us take one more example. Let f vector is z cosine x sin y I plus z sin x cosine y j plus e power z k, so that f dot curl f is 0. So first we need to find the curl of f. So here f equal to z cosine x sin y I plus z sin x cosine y j plus e power z k. Now let us find curl of f. So curl of f equal to I j k del by del x del by del y del by del z, z cosine x sin y, z sin x cosine y, and e power z. So this is equal to I. Now del by del y of e power z minus del by del z of z sin x cosine y minus j del by del x of e power z minus del by del z of z cosine x sin y plus k del by del x of z sin x cosine y minus del by del y of z cosine x sin y equal to I. Now del by del y of e power z is 0 minus del by del z of z sin x cosine y. So that is sin x cosine y. Then minus j del by del x of e power z is 0 minus del by del z of z cosine x sin y. So z. So that is cosine x sin y plus k del by del x of z sin x cosine y. So derivative of sin x, z cosine x cosine y minus del by del y of z cosine x sin y. So here cosine y z. So minus z cosine x cosine y. So this is equal to minus I sin x cosine y plus j cosine x sin y plus k z cosine x cosine y minus z cosine x cosine y. So that is 0. Z cosine x cosine y. So this is 0. This is nothing but the curl of f. Now what we wish? We wish f dot curl f. So again let us write f and then we take the dot product. So what is f? So f equal to z cosine x sin y. Z cosine x sin y I. Then z sin x cosine y. Z sin x cosine y j and plus e power z k. So this is f, this is curl f, and we want to take the dot product of that. So f dot curl f, we know how to take the dot product. So z cosine x sin y and multiply with this sin x cosine y with negative sign. So minus sin x cosine y. So I component, and now j component. So plus z sin x cosine y and j component here cosine x sin y. Here e power z, but here it is 0 k. So that is 0. And so here you can see that both terms opposite sign, same term, and so that is nothing but 0. So f dot curl f is 0, and so it is verified. Let us take one more example. Okay, I just stop here and give some examples as homework. So first, compute divergence of f and curl of f, where f is x square y I minus z cube minus 3x j plus 4y square k. F equal to 3x plus 2z square I plus x cube y square over z j, then minus z minus 7x k. Let us take one more. So check whether f is conservative. Now conservative means irrotational, means its curl of f is 0 vector. Then you can say that f is irrotational or conservative. So we need to check whether the given vector is conservative or not. So basically you need to find curl. If it is 0 vector, then it is conservative. If it is not 0 vector, then it is not conservative. 4y square plus 3x square y over z square I plus 8xy plus x cube over z square j plus 11 minus 2x cube y over z cube k. And second, f is 6xi plus 2y minus y square j plus 6z minus x cube k. Thank you.